Okay, good morning, and let's get started. My name is Chetan Mehta. I'm the founder and principal instructor at Skillcubator Training and Placement Institute. And this session is our first session on data analysis, training and placement program. So Shakira, I know we have been talking for a couple of, I would say, 2 months or so. So I know you, but if you want to just quickly introduce yourself, and likewise, I would request others to introduce in terms of their background, education, work experience, and what exactly they're looking from this training program.
Yeah, thank you for, the consistent communication with me. But yeah, I'm Shakira. I'm currently working as a quality control analyst in the biotech industry. I study biology. And yeah, I'm just looking right now for a career change to pivot. I'm not really liking what I'm doing. There's not a lot of growth. Learned what I needed to learn. And yeah, it just seems like I'm just ready to take some next steps forward. So yeah, I've been interested in data analysis, and yeah, I'm a total beginner as far as all the different programs. But yeah, I'm excited. So I'm
Okay,
here.
thank you. Shanice, how about you? If you're talking,
Hi, can everybody hear me? I'm sorry.
yeah, I can hear you.
Hi. So I'm Shanice. I have been like all over the place. Like I have done customer service. I have done call centers, in the hospital and in other industries. And I'm just looking for something different. I've done data entry, and it seems like something pretty cool. So I've been looking into data analytics and just to have something extra on my resume. I actually do graduate next year with a bachelor's degree in health administration. Um, so I just want something to add to my resume, and just to show that I have flexible skills, and so that any industry will be willing to take me.
Got it. Okay, thank you. Thanks, Shanice. Mukul, what about you?
Yeah. Hi, sir.
Hello.
Yeah, sir. I completed my post graduation in web development, but I'm looking for a new opportunity in my field. I have experience, like 1 year experience in my home country as a software developer, like front end developer. But here I'm looking for a new opportunities. So I just want to learn a new skill as a data analysis. So I'm excited. Honestly.
Okay, cool. Thank
Yeah.
you. And we have Ken. Hey, Ken. Okay, Ken, if you want to introduce yourself, and if you're talking, you're on mute. Or you can type in if you think you are not able to speak.
Can you hear me?
Oh, yeah, now perfect.
Oh, okay. Yeah, I've been in real estate for the last 25 years. I'm looking to get out of it and get into something else that's a little more stable. And I've been interested in data analytics for a little over a year now.
Oh, nice.
Done some studying in it, but not enough to where I feel comfortable.
Got it. Okay, thank you. Cool. And as I said in the beginning, my name is Chetan Mehta. I'm the founder and principal instructor at Skillcubator. So this course is on data analysis or analytics. Now, I'm going to cover a few things today, and there are 3 main components in this training. One is the most basic tool, which oftentimes is used by the data analysts all over the world, and that is Excel. Microsoft Excel. Similar to Excel, we have Google Sheet, but we'll stick to Excel because that's going to be one of the most commonly used tools by the data analyst. So think about Excel as, the bread and butter for data analyst. It's simple. Of course, I don't know how much experience you guys have. We'll talk about that, but it can go from basic to intermediate to advanced level. And you can do so many things using Excel. And it has got so many features, so many functions, which of course we don't need to know every single thing or all the functions it has, but we need to know the most commonly used functions that a data analyst uses on a day-to-day basis. So that is one thing. The second part is SQL, structured query language. Now, SQL is not a proper programming language. It's not like Java, .NET, or C, C++. It is more of a clause-based language where we use simple clauses to frame sentences, but those sentences that can be understood by an application, by a software. Just like right now, we are talking in English, we are using the same common language so that we all can communicate. Similarly, we have to use a language which a software can understand. So SQL is not that difficult, and it is used to communicate with a database. Okay, we'll get into more details as we go forward. And the third most important, you can say, skill for a data analyst is to do data visualization. Because data can be huge, right? It can be 100 rows, it can be 1,000 rows of data, it can be 10,000 rows of data, maybe more. And same goes with a column. It can basically have 1 million set of data that we need to see, we need to understand. How do you do that? You can't just go row by row or column by column to see and understand, because that's not how our mind functions, right? If I show you, 100 numbers, it's difficult to understand or see some patterns, see some meaningful insights into it. But when we convert that number into some form like charts or some sort of diagram, some sort of model, then it makes sense. Now you can visualize that, okay, that is what the growth trend is, or that is what the population growth is between 2005 and 2020, something like that, right? So when we visualize things, it makes it much more easy to understand, to interpret. And that is also a very important skill for a data analyst, to convert these data into some sort of visual aids. Okay, so we'll look into these three aspects. That's going to be your focus for the next, I would say, 2 months. Now, how familiar you guys are with Microsoft Excel? On a scale of, let's say, 0 to 10, 0 being never used, 10 being very proficient.
Right now, I'm probably like a good, I don't even know, maybe 5.
Okay.
I forgot a lot of like graphs and all that good stuff.
Okay, so Shanice is saying for 9, that is good. Okay, Shakira, I'll put you at 5 then, okay? Because you have used in the past, right? And if you look at it, it's going to be, I think you'll pick it up fast, I believe.
Yes, definitely.
What about you, Mukul?
Sorry, sir. Can you say it again?
So I was asking, on a scale of 0 to 10, where do you rate your Excel skills? 0 being never used, 10 being very proficient.
Like, I think like it's 2 or 3, but I know about Excel, like not that very much. I use in like for very small
Okay,
parts. So yeah, like 2 or 3. That's it.
no problem. Thank you. And what about you, Ken?
I'd probably have to say about the same thing, about 2 or 3.
Okay, cool. No problem. Okay, so we have got Shanice, who is at 9, Shakira, roughly, I will say 5, and Mukul and Ken, well, let's put at 2 or 3, right? So that's where we are. Okay, no issues. And that's exactly what we are here for, to upskill you guys with all the required skills that you need to have to succeed as data analyst. So Shani is just curious to know what all have you used in Excel? I'm sure I don't even want to ask you all the basic functions, but besides that, I'm sure you might have used pivot tables, VLOOKUP, HLOOKUP, creating.
Yeah, we worked like the last job that I had, we used it a lot. We used Microsoft, like all the different offices, like the PowerPoint and the Excel sheets and all of that. So I did learn a lot from the last time. I don't know all the names of everything that we use. Like I can tell you how it looks, and then I
Okay.
know how to work it, but I don't know the name.
Okay, no worries. Yeah, as we go along, I think all of you will, if you have used it in the past, it will come back, right, as a good fond memory. If you have not used it, then we will teach you how to use it. Okay, so that's good. And okay, so let's start with the first one to understand what is data, right? Because we are talking about data analysis. So first, let's understand what is data. And let's keep it more like a, very free-flowing communication, two-way communication, so that it's going to be more engaging instead of just a monologue from my end. So I want to make it more interactive, more engaging from all of us. So what is a data in your own words?
And data is information, or like yeah, it's like information or
Okay. So data is information, okay? Partly right, okay? But I would say it this way, data can be converted into information. Okay, data is not equal to information, but yes, data is a source from which we can convert that into some meaningful information. Do you guys agree? Shanice,
Yeah.
Shakir, Ken.
Yes.
Okay. So see, data is something that is like a fact, right? When we see a data, like a date of birth, it's a fact. It's not like maybe yes, maybe no. It's a fact. A date, let's say today is what? March 30th, Sunday. It's a fact. It's a data we are talking about, right? Now, data can be in different forms. First of all, when we have a data, we need to make sure that a data is based on some fact, which can be analyzed, which can be converted into some meaningful information. Because just taking a data is not going to help us. We need to convert that data into some meaningful information, meaningful shape, so that we can make some informed decisions based on that. Like, for example, today we said, right, at so and so time, we are going to start this training, right? That's a fact. That's a data. And by putting those things into a more meaningful information, we could interpret that this is going to be a first batch for data analysis at 11 a.m. EST. Now, data can be in different ways. Usually what we think of a data is when we see something like a text, like numbers, right? Mostly we think about data is equivalent to numbers. But it's not only numbers, any text, numbers, it can be special characters, it can be images like a photos, it can be an audio clip, it can be a video clip. All of that is data. Now, these days, we all are aware, right? On social media, you see a lot of images, you see a lot of reels, you see a lot of messages, right? I can put any sort of, not any, but I can put a message or I can type in my comments, not message, but I would say comments. We see a lot of photos on your profile, or right now, I have my profile photo. Shakira has a photo when we log in. That's an image. Audio, right now we are talking, it's getting recorded. And that recording is also an audio. I mean, it's also a data, but it's in the form of an audio. And we can also do the video. If I switch on the video right now, we can also capture all the, faces of all of us, and that's also a data. In today's environment, we are surrounded by data. And the most important part is we need to now use the data and make some meaningful information out of it so that we can help somebody. It can be an organization, it can be top level management, it can be mid-level management, to make some informed decisions based on that. They can make decisions which are strategic in nature, or they are tactical in nature, or operational in nature. Strategic would be, okay, based on this information, I think we should launch a new product. Or based on this information, after we analyze a huge set of data, we believe that we should venture out into a new market altogether. These are strategic decisions, major decisions that's going to impact the organization in a very big way. A tactical decision would be something which will impact a limited group of people. Let's say based on some analysis of data, a production department determined that this defect is because of the way we are doing certain things in the manufacturing process. So that's basically what they will infer, and they will fix that problem so that they don't see defects coming out of the production system. These are tactical decisions. And operational decisions are like a day-to-day basis, right? Very, for example, let's say in the HR department, you want to improve, let's say, timekeeping, right? So you have a raw data. Based on the raw data, you analyze the raw data, and then you come up with some solution that will improve the timekeeping process. Okay. In short, when you convert a data into a meaningful information, it will help the management of that firm to make informed decisions, whether it's a strategic decision, whether it's tactical decisions, or whether it's operational decisions. Now, as of today, as we said, data is all over the place. But then we have got different types of data. We got structured data, we have got unstructured data, and we have got a mix of both, which is a combination of structured data and unstructured data. So the first thing is very simple to understand when we say structured data. A structured data is something which has got a consistent or consistency in terms of what data are we capturing, the format of the data in which we are going to capture, the validations that we want to put on that data. These are consistent. For example, let me also show you what we mean by that. So for example, I'm just opening a spreadsheet here. It's an Excel. I got, let's say, first name. Last name. Date of birth. SSN. Okay, I got these many. So this is what we call data element. That means I'm going to capture the first name in column E, last name in column F, date of birth in column G, SSN in column H, and phone number in column I. Okay, so I will not store my phone number anywhere else but column I. Same thing with all the other data elements. It has to be stored in the same column. Now let's say the first name of a person, John Doe. Okay, so I got the first name here, last name as Doe. Let's say date of birth is, we'll say June 5th, 1990. This is a date. It's in a particular format. I cannot put anything there. I cannot say June 5th, 1990. It's not a valid entry. It has to be in a certain format. SSN, it has to be exactly the same number of characters that SSN should have. So let's say we'll just put some dummy numbers here. Let's suppose that's an SSN of John, and then phone number. I'll just put my phone number. This is called a structured data. Why? Because I'm going to store the first name in a particular column. The data structure is also going to be of a particular type. For example, we are saying it is going to be alphanumeric. We'll talk about these in more detail as we go forward, but right now I'm saying I'm going to allow alphabets and numbers in this cell. By the way, this is a cell, okay? Every single rectangle is a cell here. I'm going to allow alphabets and numbers in this cell. Date of birth has to be in a particular format: month, day, year. SSN has to be exactly in this format. And phone number has to be in exactly this format. It's a structured data. Now, when you have a structured data, it becomes very easy to do analysis. Why? Because now you know exactly the layout of the data, the format of the data, the structure of the data, and you can do your slicing and dicing of the data very easily. You don't have to do anything there. And mostly you will be dealing with a structured data as a data analyst. Any questions so far?
No, that's good.
Now let's talk about unstructured data. Now, unstructured data is all about, as you can see, or you can figure it out, that something which is not structured. Now, when I look, let me show you what I mean by that. I'm just going to go to my LinkedIn profile. So if you look at this profile, I got data which is here. We have an image, right? I have an image here. I got some documents uploaded here. So I can click on that. See, it's going to take me somewhere else. I don't want to kind of go there. See, I've got a document. Within the document, I've got images, I've got text. Then I got a bit of structured data here, right? And then I got, again, data, which is, all this is structured data because it is in a particular format. But here, it's not structured. People can put their comments, whatever they want to. Somebody can just put 2-word comment. Somebody can add 50 words there, right? So it's a mix of both. Same thing goes with social media. When you put a post or you put a reel or short, whatever it is, it's a mix of everything. It is video, It has got audio. People will start posting their comments. That's a text. Then they can also put some emojis, or they can put some other images as part of their comments. So that is what we call unstructured data. Unstructured data can also be converted, and you can do the same thing that you can do with a structured data, but it needs a bit of cleaning process or cleansing process. You have to make sure that you convert that unstructured data into some sort of structured data. Okay. And then we have got the third category, which is a mix of both structured data and unstructured data. Now, what this means, again, this usually we don't deal with this part, but just to make sure that we understand this. See, when systems talk to each other, let's say we've got application A that is going to talk to application B. So they will talk using some communication protocol. They will use, let's say, a web service, or they will use some sort of, let's say EDI transaction. In that, it will say, this is exactly how I will send the request. That is a structured part. It will send, think about this as a template. It will send a template. For example, application A has to get some data from application B. So application A will send a template to application B saying, this is a template, fill this template and send it back to me. So the template is structured data, but then the response we get in that template can be unstructured. Okay, so it's a mix of both, basically structured and unstructured. But as a data analyst, you'll be dealing 90% or maybe more, you'll be dealing with a structured data, because data that lives in Excel sheets or that lives in database, they are structured data. Any questions anyone has?
No.
So some examples of data, as we just now said, like numerical data, it can be age of a person, like a date of birth, height, temperature of the atmosphere. It can be phone number, it can be SSN, it can be email. I won't say email address is a text data, but anywhere we have numbers, it's a numerical data. Okay. Income of a person, it's a numerical data. Textual data, as I said, it can be emails or articles, name of a person, address, all of that is a textual data. Visual data, it can be photos like images, emojis. We also have those GIF, right? What we call GIF, something which I've seen a lot of times people post it at that. That's also visual data. It can be in the form of charts. Chart can be a bar chart, pie chart, linear chart, histogram, all those, they are visual data. And then audio data, as I said, it can be, how we listen to music. Anything where we have an audio is also data. But as a data analyst, you'll be dealing mostly with numerical data, with textual data, and with visual data. In the visual data, charts, graphs, all of those. Now, as I said, that data is not equal to information. Yes, the source of information is data. So whenever we have a raw data, we need to convert that raw data into a more meaningful information. We have to use the tools and techniques that will teach you and make sure that we convert that raw data into information, which in turn will be used by stakeholders to make some key decisions. That's very important to know. And if you look at this chart, so we may have data coming from different sources, right? Oftentimes you will have multiple sources from where you will get the data. Now that data is raw data. It has not been processed. Now you have to convert that data into information using different tools and techniques like spreadsheet. Spreadsheet, just now what we saw, it can be Microsoft Excel, it can be Google Sheet. These are typically two which people use. Mostly we use Excel, but those who don't have Excel, we can also use Google Sheet. They do the same thing. Google Sheet is basically a replica of Excel. Then SQL, structured query language. We'll be using Oracle DBMS, and we have a expert on that. I'm going to bring him to teach SQL and data visualization. So just to give you heads up that I'm going to cover the Excel part. And then when we come to SQL and data visualization, we will have an expert on that who is going to come and teach you. He's a certified data analyst / data scientist professional with 12 plus years of experience. So I want him to take these two topics because he has been doing it for the last 4 years for us, and he's very good in these two areas. And my expertise is more into Excel, data analysis, business analysis, project management, agile, all of those, process management. But I do teach the Excel part. Okay. So you convert the data into information using three things. One is Excel or Google Sheet. Second is SQL, structured query language, and then data visualization techniques. And in that, we are going to use Power BI. So Power BI is a software. We used to use Tableau before, but Tableau is now out of, you can say, fashion, or a lot of companies have moved away from Tableau and switched to Power BI because Power BI has got more features and it is much more cost effective as compared to Tableau. So we will be using Power BI to teach you data visualization techniques. So combined with all this, you'll convert the data into information. That's basically what your job of a data analyst will be. Any questions, anyone? There's no questions. Now let's talk about the different types of data analysis. So a data analysis can be classified into different segments based on what you want to achieve from it. So there are four main types of data analysis: descriptive analysis, then we got diagnostic analysis, then we got predictive analysis, and prescriptive analysis. Okay. So we need to know all four of these, and using the tools and techniques that I just now mentioned, we can do all four using Excel or Google Sheet, SQL, and Power BI. So the first thing is descriptive analysis. So what comes to your mind when we say descriptive analysis?
Is describing a particular thing?
Sorry?
Is describing a particular thing? Like it's describing what
Yes.
entity we're using or something like that?
I can hear you, Shanice, but I think it's no, I can't really. It's very as if you're talking from a bit far. Is it same for others or just me? I don't know.
Yeah, no, it's
Can you hear me
kind of
now?
Yeah, this is good.
that's yes.
Yeah, Shanice, you're saying something?
Oh yeah, I was saying it's kind of like describing the entity or whatever we're using or something like that. Like a descriptive, it's like an
Yes.
entity, like describing something.
Describing something, right? What happened, right? Basically, that's what descriptive analysis is. So descriptive analysis is the first and the most basic, most fundamental type of analysis that we all should be aware of, which answers what happened, right? It's not going to give you insights into why it happened, what can be done about it, nothing like that. It's only going to tell us what happened. So based on the data we have, it tells you this is what happened. Like, simple examples can be like how we go for annual check, health check, right? We do the blood work, we do all the stuff, and then we get the report at the, once we are done. It tells us what happened in the last 1 year. It's not going to tell you why it happened, what can be done to fix the problem. It's just going to tell us what happened. Or if, let's say, we have got sales data, we can tell the story in terms of we can summarize the sales data by, let's say, by a product or by, let's say, a particular time frame. Let's say in the last quarter, what was the sales of product A, or what was the sales of uh, a product in a particular region. Or if you want to do it by a certain segment, by the team, let's say, tell me the sales that was done by team A versus team B. How many of you guys do some sort of what happened analysis on a day-to-day basis?
Mm,
Hmm.
I'm trying to think. I mean, maybe if like some of our that like some data, if we get like out of spec results,
Mhm.
I don't know, something around those lines. Like we'll say like,
Yeah. See,
well,
simple day-to-day example,
mhm.
the way I do is, let's say, I'm sure all the bank apps do that now. It will tell you what was the expense for this month per category. Like when I log in into my banking app, it tells me that last month I spent this much of amount or percentage on groceries, on gas, on utilities, on mortgage, whatever it is. It tells me that. It just tells me what happened. It doesn't tell me, why. It doesn't tell me what I can do to reduce it, but it just tells me what happened,
Okay, yeah.
right? So we all do this knowingly, unknowingly. We all do this descriptive analysis to, understand what is going on. Any other example, Mukul or Shanice, you can think of?
Yeah, like exactly you're saying that's happened, that's completed. Like if if I walked 2 kilometers in my morning walk, so that's the data. Like this
Yeah,
is just
yes. You
yeah,
all have probably, if you have that's a smartwatch or fit,
yeah,
right? It
like
tracks how many calories you burned,
how many calories I burn.
right? Yeah,
That's happened already. Like, we cannot change that. We can't do anything in the
yeah,
yeah.
exactly. Right. So it gives you all sorts of data, your calorie data, maybe your blood pressure, your, I don't know if it's giving you anything else, but
Yeah.
basically what it's telling you that this is what happened after
Yeah.
you did your workout.
Yeah.
Correct? Now, it has got advantages as well as some disadvantages or limit. I won't say disadvantage. There's no disadvantage, but there is limitation, I would say. Advantage, of course, it provides you with very good understanding and insights into what happened. Like just example, like after 2 hours of workout, you get to know that or maybe 1 hour, you got to know that you burned these many calories, your blood pressure is good, and whatever is showing it to you, you get that understanding, right? And it gives you in a very easy way that you can interpret and digest that data. Like here, let's say you are a stakeholder because you are the one who is going to look at the data. So it's easy for you to understand, interpret the data. And this is the most important part is it becomes your starting point for further analysis. Let's say in the previous slide, I told you, right? Let's say I go for an annual health check. My cholesterol level is not in range. Now that tells me what happened. But now it becomes a basis for my doctor to tell what we can do to fix it, why it happened, what can be done to reduce it. That's the next step, but this is going to be the baseline or the starting point for further analysis. Right? Now, limitation, just what I said, that it doesn't give you why it happened, or it doesn't give you the root cause. Let's say, I go for my annual check, my cholesterol is not in range. It will tell me what happened, but it doesn't tell me why it happened. The doctor has to now investigate. Maybe my lifestyle is not good, or maybe it's genetic, or maybe something else is going on due to which the cholesterol level is not in range. So now the next step is it is going to be the cause and effect relationship. What we call the root cause analysis has to be done. But I won't say it's it's a limitation per se, but yes, we need to go now one step further and do root cause analysis, because just descriptive analysis is not going to tell us why it happened. It's not going to give us the root cause of why this problem occurred. The second thing is a descriptive analysis will not answer what can or what will happen in future. It fails to predict the future outcome or behavior. Okay. So these are the limitations, but of course, doesn't matter. We have to start from descriptive analysis to go forward. You cannot skip this part. And yes, last but not the least, it is based on historical data. And of course, any analysis starts with historical data. So it is basically what it is. You can't just skip this part. But now this descriptive analysis will lead to the next level of analysis, which is what we call diagnostic analysis. Now, we all understand the word diagnostic. What does it mean? We have to diagnose, we have to do some further analysis and see why it happened. Like, let's say my car is not functioning well. I'll take it to the garage and they will check what happened. First thing they will see what happened. That is descriptive analysis. And then they will see why it is happening. These two are separate things. So that is what the second analysis is. It's called diagnostic analysis. It goes beyond what happened, and now it is focusing on why it happened or why it is happening by analyzing the historical data. Okay, and this is where we will start doing some further analysis, like root cause analysis, look into the patterns, look into some sort of correlation analysis, which event was responsible for this problem. So all these things will be done as part of diagnostic analysis. Like examples, I'm taking the same examples from the previous one. So let's say the A1C level went up, right, in the annual report. A patient goes to see the doctor, they do the blood work. What happened is done, right? That's the first step. The descriptive analysis is done. A1C level went up. Let's say the range is what, 5.6. It came to 6.0, for example. Now, we need to understand why A1C level went up from last time. It was 5.5, but now it's 6.0. Why it happened? So now we are comparing with the historical data, and now we are trying to do some root cause analysis to find out what was the reason that it went up from 5.5 to 6. So if you see everywhere, we are trying to answer why. Why sales of a product went down by 25% in a particular region. Why the electricity consumption went up by 50% as compared to last year for the same duration. And I did this is coming from one of my recent observation. My electricity consumption went up by almost 40% in winter, despite the fact the gas consumption should go up, right, in winter, not the electricity consumption. For the same year, last year, I compared for the Jan and Feb, I compared that with this year, it's almost 40% up. That's basically, I'm trying to figure out why it happened. Are you guys with me?
Yes, sir.
Yes.
Now again, yeah. Shanice, you have a question? Okay. So some of the advantages of diagnostic analysis is it takes the problem into a more detailed analysis, right? We can see much more detailed insights into a problem so that we can make some more informed decisions. Right? When we have a good diagnostic done, it also helps us to prevent from making the same mistakes, right? Or let's say if we want to, it's not something negative. Let's say the sales of a product went up by 25% in the last 4 months, and we want to diagnose. We want to see why this went up so that we can replicate that across other products if possible. So it's not always negative. It can also be positive, which you want to replicate, you want to use in future. That's what the second bullet point says, that by doing a diagnostic analysis, you can stop making the same mistakes and correct the problem, or you can promote making the right decisions, or keep doing the right or keep making the right decisions, or keep promoting best practices so that you can get benefit out of it in future. So it can be both ways. Okay, it's not always negative. It can also be positive. Sometimes we don't know, okay, something, we got a better result, but we didn't really know why. So we want to do some diagnostic analysis and see, okay, what led to this positive outcome, so that we can keep doing it for future as well. Okay. It helps us to do root cause analysis. Now, anybody has done a root cause analysis before?
No.
Okay. Do you guys understand what this concept is? So I'll talk about that in the next session. So root cause analysis is when we have a problem, but we want to understand the symptoms. I mean, when we have a symptom, not sorry, my bad. When we have a symptom of a problem, but we want to get to the root cause, we want to understand the underlying factors that's causing that symptom. For example, let's say the car example. My car is not functioning as per my expectation. So it's a problem, correct? But it's a symptom to an underlying problem. There is something going on which I don't know. It can be just one problem. It can be some multiple problems going on. But now we want to understand the root causes that's leading to the problem. Like a few days back, I had this issue. I was coming back in my vehicle, and all of a sudden it started making loud noise from the front. Right now, I knew that's a problem. I never heard that sound before, but this weird sound started coming from the front, which is basically where the engine is. And luckily, I was very close to my house. I reached my house and I saw some fluid leaking in my driveway. So I knew that there is some problem going on. So then I towed my car to the garage, and that they did the diagnostic check, and they found that some gasket was leaking. It just, burst, and because of that, the coolant was leaking. So they did a diagnostic check, and they found out the root cause. The root cause was that gasket got burst, because of which the coolant was leaking. Right? So that is what a root cause analysis is. So we know there is a problem going on, but we don't know what's causing it. What are the root cause or causes that's leading to the problem? Okay. Now, when we do a root cause analysis, based on that, we can understand what is going on, why it happened, and based on that, we can make improvements. We can stop making the same mistakes, or we can fix the problem, or we can promote what we were doing, like best practices, or we can continue doing the right things, which led to some better positive outcome. Limitations of diagnostic analysis is simple: garbage in, garbage out. Meaning it depends on the quality of the data, the source of the data from where you are getting it, and the quantity of data. If my source is not coming, my data is not coming from a genuine source, if I'm not getting it from a reliable source, that means my outcome will also be not genuine, may not be reliable. Right? So source is important. We need to get the data from the right source, from the genuine source, which we can rely upon, that the data is correct. Quantity of the data is also important. See, I cannot make some meaningful conclusion based on a very small set of data. For example, let's say, today I take an exam and I don't do good. That doesn't mean that I cannot do good in future as well. Maybe I did not prepare, I was not informed, or I was not in a good, frame of mind to take the exam. So you need to be consistent in terms of taking the data. I cannot just say, okay, because this person did not do well in one exam, he or she is not a good student. Or take the example of, sportsman. In one game, if a player cannot perform well, do we say that this player is bad? We don't, right? We have to look at certain things like we have to look at a good amount of data to conclude whether that player is good or bad. So maybe in the whole season, if this player did not go well or did not do well, then yes, we can say, okay, this player's performance was bad in this season, or maybe last year. But just 1 or 2 games, we cannot conclude. That's what I say. Quantity of data is also important. We need to take a good set of data so that we are confident that this amount of data will give us some realistic outcome. And quality of data, of course, as I said, that we need to make sure that the data is coming from the right source, plus the quality of data is also good. So to give an example of quality of data, in one of my projects, we had, just to tell you a short story, we had one system in which we had to feed the data. Now, one source of data was coming from a different system. There was one system which was feeding the data into this system. So it was automatic. It was system to system communication. But then there was also one group of people who would enter the data manually into this system. So the data that was entered manually in the system was oftentimes not very good data. The quality of data was not good because they would just type in some data which was not correct, or they would type in duplicate data again. So one person would enter 2 or 3 times the same data, or sometimes they would forget to enter the data. So we would miss the data altogether. So the quality of data goes down when you have this type of problem, and we don't want that. So these are the limitations of a diagnostic analysis. Okay, then comes predictive analysis. Now we all know what prediction means. Something that you want to forecast in future. Now here we are not just doing it based on what you feel or I feel. We're doing it based on historical data. So predictive analysis will help you to forecast what's going to happen in future, or what is going to be the trend in future based on the data that we already have. So it answers what is going to happen in the future. Now, this is very important, especially for the management, because they want to see this, right? They want to take this and see what will happen in future. What is going to happen in future? Now they can use this in their strategic planning, or they can make use of this information in the risk management. Or they can make a better decisions based on that. Now, taking the same example, right? A1C level of a person is not in check. So what is going to happen if this person continues with the same lifestyle? What will happen? Well, maybe it will lead to kidney failure. Maybe this person will have to go on insulin, right? These things will happen. What is going to be the future sales or profit for a particular product in a particular market in FY25 or FY26, looking at the same trend, looking at the same projection. So this answers the future, but not based on what you feel or I feel, but based on the historical data, based on the trends, based on the correlation of the data. Oh, we all do this, right? We all do some predictive analysis, but oftentimes we don't use data. We use our judgment, we use our, sometimes we use our uh, emotions, you can say, or what we feel, correct? Don't we do this? We are trying to predict future based on the current situation. Anybody can give me an example of doing some predictive analysis for yourself, maybe in your personal life or your professional life? Like, I'll give me an example. 3 years back, um, or 4 years back, I wanted to get into cloud computing. Cloud computing was new for me, except I knew um, the concepts. But I was hired as a PM, IT project manager for cloud computing project. So now I knew that if I do this certification, I'll be much more successful. Of course, as I said, I didn't do based on any data, but that was like my a predictive analysis. What is going to happen in future if I do this? So I said, if I do this certification, it's going to help me to become a much better IT PM. And I'm sure we all do this, right? I mean, you guys are here. That itself says that you have done something, it's like a forecasting for your career. Like you're saying, okay, if I do this training and I get into a better job, I will earn more. I'll be more flexible in terms of remote jobs. I want to build a career in data analysis because that's where the future is, isn't it?
Yes.
And of course, the advantages that we can uh, see what is going to happen in future, right? That means it promotes a proactive decision making than reactive. Reactive means after the fact, we are now making a decision, which is not good, right? You don't want to react to things. You want to plan things proactively. So when you do predictive analysis, when you are trying to see what's going to happen in future, you can plan it ahead of time because now you know. Of course, it's not 100% guarantee, but you have got a better chance of uh, succeeding or success here, not succeeding, but success, because now you are being more proactive. So that is one thing. Second, it gives a much more competitive edge to any organization who will engage with predictive analysis because now they are trying to get ahead of others. When you try to predict future based on data, based on scientific means, now you have a much more informed, you can say, set of information that you can use and you can make better decisions. And you don't have to work or you don't have to worry about, you know, um, any guesswork or anything of that sort. You're doing this solely based on scientific principles, based on analytical thought process. You have a data to back you up. And limitation, as I said, it is very much dependent on the source of the data, the quantity of the data, and the quality of data. If you got this good source or reliable source, good quantity of data, and good quality of data, yes, you can do predictive analysis and come up with a better decision-making process. And last but not the least, prescriptive analysis. Now, this is the most advanced approach you can follow, which tells you not only what happened, why it happened, what will happen in future, but it will also tell you what we should do to either stop it or to promote it. So when we say, let's say we have a problem. Do you guys want to solve a problem? Yes or no? Let's say the sales of a particular product has been going down for the last couple of months. That's a problem, right? For any company, that's a problem. And you don't want this problem to exist. So prescriptive analysis will tell you what should be done so that the sales of this product can be improved. We can boost up the sales of this product. Similarly, let's say, take the same example. We launched a product, and this product is doing really good in a particular region of a country. Now we did what happened, why it happened, right? What will happen in future, but we also want what we should do to take advantage of the same strategy so that we can replicate across other products. So this is what prescriptive analysis is. But oftentimes we think about a problem, but it can also be applied in case if you want to take advantage of any opportunity. Okay, you can use both ways, but this is the most advanced form of, you can say, analysis, analytics, and this will oftentimes be used by data scientists. Usually data analysts may not be involved in this level of analysis. Data scientists are the ones who will be doing this. And as I said, it is going to give you a very clear, actionable guidance in terms of what needs to be done, right? Because now it's also prescribing the actions that you must take to solve the problem, or if you want to take advantage of an opportunity. It will help anyone who is going to depend on making a decision. It makes it very easy for them because now they are telling you, it's getting you the solution. It's prescribing you what actions you should take. Hence, it promotes more efficiency, more productivity, profitability, all the good stuff. It also helps us to manage the risk because when we know, right, what actions we must take in future, we can better manage all the possible risk that comes with it. We can think ahead. It boils down to being proactive. Right? And limitation, I would say, it needs a high level of expertise in terms of reading the data, creating models, creating simulations. And for this, as I said, one has to be, at that very advanced level of data analysis. We'll need to know some of the programming languages as well, R, Python, SAS, SAS, SPSS, all those languages, all the software, because here we are trying to come up with some models. Okay, mathematical models, it also involves statistics. So this one, as I said, this is mostly done by data scientists. But descriptive, diagnostic, predictive, yes, you will be very much involved. Any questions, anyone? Shakira, Mukul, Shanice?
No. Mhm.
Is it something you're enjoying?
Yeah, it's interesting.
Okay, so I'm going to switch my gear and open Excel. Let me just. So this is my Excel, okay? I'm going to do some basic of Excel today, and then we'll get into more detailed discussion next week. So usually the sessions will be Saturday, Sunday from 11 a.m. EST to 1:30 p.m. EST. Is this time okay for all of you?
Yeah.
Can you tell me the time one more time, please?
So 11 a.m. EST to 1:30 p.m. EST, Saturday and Sunday.
Okay, that's fine. Thank you.
Okay. Mukul, what about you?
Yeah,
Okay.
sir. Yes. Okay. Yeah.
So Excel is bunch of sheets. Okay. I'm going to open one sheet here, but you can click on this plus icon and you can add more sheets, as many as you want. Now, this is my blank sheet. Every sheet has got rows. If you see A, B, C, and I can go all the way to XFD. I got these many columns. My bad. These are all the columns. Okay. Right from A to XFD, all the columns are listed. And then 1 through all the way, I think we have got, yeah, all the way down. I got these many rows. Okay. 1 million rows listed here. It's got what? 1,048,576 rows. Now, within these columns and rows, I got cells. Each rectangle is a cell, okay, in which we will be storing a data. Now, for example, if I enter the data here, let's say I put my name here. Now, this becomes a data which is stored in A1 cell. A is my column name, 1 is my row name. So this becomes my cell name. You see on the A1 here, it gives me that name of that cell. If I go down, it becomes A2, A3. Likewise, it will keep changing. If I put here, let's say I put my last name here. Now it becomes B1 because I'm in the second column, but I'm in the same row. Okay. So we'll take one step at a time. I'm going to show you some how to navigate this software, and then we'll do some hands-on from next week. So first thing first, let me close this. I want to launch Excel. Blank workbook. Okay, there you go. File, let's talk about file. Here you got some basic functions like you want to open a new file, you want to open an existing file. It will give you information about this book. You want to save it. It will tell you where to save. It's giving me option whether I want to save it on my OneDrive or my local PC. I can also share it with others. Like if I want to share with you guys, I can click on this and it will tell me from where I can share. You can save as PDF. If you want to convert this into a PDF document, you can do that. Print, again, these are very basic features. You can print, you can share from here as well, share as PDF link, export. Again, this is again same as converting it into PDF, but I can export it into not only PDF, but I can also export into different formats. I haven't used this feature, but something you can do. Close, as it says, you can close the file. Okay, that's in file. Usually you will stick to home to begin with. In this home tab, you got all the basic functions that you will need. The most commonly one, it will be this section where you can see the font type, font size, whether it's a size of the font, whether you want to make it big, small, bold, italics, underline. You want to, make borders, you can do that. Let's say I want to create a border here. I'll select and I'll say all borders. There you go. Right. And you can do bunch of things. You want to kind of make it a thick border on the outer side. There you go. You can also increase zoom in, zoom out by clicking this option. Zoom in is this one. Zoom out is this one. Okay. Here you can, if you want to do shading, you can do shading. If you want to undo it, you can simply undo it from here, or you can also do it from here. Select and say no fill. It will remove. Okay. If you want to do your text color, you want to change the font color, you can do it from here. Let's say my name and change the color to red. There you go. Okay. This panel will tell you whether you want to, or will help you how to format your data. Let's say I want to put it in the middle. Okay. Now, right now it's in bottom. I want to center it. So I'll click on this one. Now it's in center from top, bottom, and left, right. If I want to change it to left, I will click on this one. It will go to left. I want to change it to the right, it will go to right. If I want to move it to the top, I'll click it on this one. If I want to move this in the bottom, I'll click here. Okay. You can also do, indentation. Again, we don't use this too much, especially for Excel, but you have an option to indent. Orientation, you can also angle it depending on how you want. Let's say you want to do vertical, you want to angle it like this, clockwise, you want to do it anti-clockwise. You can do all sorts of things like this. Again, I hardly use this. Yeah. Okay, then we'll come to wrap text. Let's say I got, just going to do this. Let's say here, I think. Let's say I'm just going to type something here. Now, if you see, the data is only in which cell?
M5.
Very good, M5. But it is going, if you see, you see that it's all over the place, right? NOP as well. It's going in all the columns. I don't want that. I want to wrap it. So just click on this. It's going to wrap it only in that cell. Okay. Now, these are something which, as and when you start working, start using it, you will get a hang of it. You don't want to see, I don't want you guys to sit and learn every single tab and learn all the functions. It's not the way you will learn this tool. When I say, okay, let's go and do a VLOOKUP, we will learn whatever is required to do VLOOKUP. Anything outside of it is not required. I'll be very frank, even as of now, I got so many features in here, which I have never used in my life, despite the fact I've been using Excel since 95, not 95, but 96, 97. But I don't know every single functions here because I never had a requirement to learn them. But yes, if I need, I will learn. It's not going to take me much time. Okay. So don't try to learn every single function in Excel. It's massive. It's huge. Let's talk about merge and center. Let's say I got this data. Again, same thing. It's in F26, right? F is a column name. 26 is a row name. Now I want to do the reverse. I don't want to wrap text. I want to merge it between column F, G, and H. I will select this and I will say merge and center. So now my data is across F, G, and H. It basically merged all three columns into one.
So if you click on G, is it going to be still F26? Like if you,
If I click on, let me do this. What are you saying?
no, like if you wrapped the merged and center, like say, is it only merged and center in F26?
Yeah.
Or if you, okay,
Yeah, it will only pick the first one.
okay.
Yeah.
Okay, all right.
So this is more about alignment. If you see, these are categories, right? Font category, alignment category, then number categories. If I go here and say, let's say I got numbers here. Let me just open a new sheet. Okay. See, I can format my cells based on my requirement. Usually you will keep it to general. But if you have a particular need that you want to format a cell or a column, let's say in currency, right? I don't want general, but I want to put a currency here. Let's say in this column, let me just select. Let me select the whole column. That means the entire column will have the same format. Okay. If I pick one, let's say I just pick one, then it's going to apply only in that cell. It's only going to format that cell. But when I select the whole column, let's say I select the whole column all the way down, it's going to go. So this one. When I select G, it's going to take me all the way down till the last row. It's going to apply. Okay. So I select this and I say I want to format this column in currency. And then I'm saying how many decimal places I want, 2, what type of symbol I want. Usually we'll stick to dollar, right? Or whatever currency you want. It's going to give you option. Let's say I want to see Japanese currency, for example. Okay. So when I put 23, it's going to automatically format it into a Japanese currency. Of course, I can put something which is not a numeric value, but if I format it, most likely I'm going to use for that purpose. Now, if I convert this, let's say I go to this and I say I don't want Japanese currency, I want to go with a dollar. There you go. Now it converted that into a dollar value. Okay, now you can do that. You can increase the decimal. You can reduce the decimal depending on what you want. Okay, so this is something which we are going to do hands-on as we go forward. I'll teach you how to use Excel, how to use basic functions, how to use intermediate functions, and some advanced functions. But since I think Mukul and Shakira, you guys are relatively new to Excel. I wanted to start from basic. I know for Shanice, you might be very much familiar with all these things, but just bear with me for this session. Next session, we are going to start working on with the data itself. Any
Yeah,
questions?
no, thank you for that refresher.
Sure, absolutely. So I think we'll stop here today. But I'll be giving you some assignment to read. And how many of you have Excel with you?
I do.
You do have, okay. Mukul, what about you? Shanice,
I have.
you have? Okay. And I think Shanice, you also have? Okay, cool. So what we'll do is one take-home assignment for you guys is to just open Excel and make yourself familiar with Excel. I don't want you guys to go all over the place. Just go with the first one. Go to the File tab and explore what it does. Then go to Home, look at font, look at alignment, look at numbers, what just now I showed you. Just play around with that. Observe what it is doing. Okay, next when we meet, I'm going to start with some basic functions of Excel using some small set of data, and then we'll also take a big set of data, which has got, let's say, 1,000 rows and 1,000 column. Okay, and I'm also going to give you a reading handout on data analysis. Just read it when you get chance so that you are better prepared when we come next time. And we'll hit straight away with Excel and start working with some mathematical functions to begin with.
Okay. Will you be able to send this PowerPoint
Yeah,
with
I'm
the
going to send that.
slide?
Yeah,
Okay.
I'll
All
send.
right. Good. Thank you.
You're welcome. Okay, any questions before we stop? Okay. Okay, so we'll stop here and have a nice rest of the Sunday. I'll talk to you soon.
Thank you,
All
sir.
right.
Thank
Thank you. Have a good one.
you too. Thank you. Bye.
Bye.